Good afternoon. Am I audible?
Yes, sir.
Okay, so let us start. Is the presentation visible?
Yes, sir.
Okay, so we have been discussing about UML as a basic framework modeling language for representing various aspects of a software system. And we have taken a detailed look at the first diagram, which is the behavioral one, the use case diagram, the actors, the use cases, and the different ways the use cases can be related by include, extend, or generalization principles. Next, we'll look into something which is the structural diagram, the class diagram, and you will find that this will be, almost known to you, except for the UML notation and the UML terminology, because since the beginning of this course, we have been talking about classes and objects. So let us get started, and in 3 modules, we'll cover this. So we first, what we look at is what are the class diagrams and what do they actually mean. So as you know, an object is a concrete entity, that exists in time and in space. So at a given point of time during execution, an object exists, and in space in the sense that it is there in the memory location somewhere. I'm sorry. So in contrast, a class represents the layout. It's only an abstraction. As I mean, you know all this, the essence of an object. As it were, for example, for a class faculty, these could be the objects. And therefore, the class faculty abstracts the name of the faculty, the designation of the faculty, and the department of the faculty. So, as in C++, Java, and other languages, in UML, which is certainly language independent, implementation independent, the class is a set of objects sharing a common structure, a common behavior, and a common semantics. And as before, a single object is simply an instance of a class. So this is kind of, as we say, is a canonical view of a form of a complex system. We are not going deep into object-oriented, presentation. But if you want, you can go back to module 4 in this presentation, and you'll see more details about that. But there are basically 2 structures which build up a system. On left, you see the class structure, which will talk about the ISA hierarchy primarily as to the specialization of one class of another and so on. And on the other side, you see an object structure, which is the HASE or part of hierarchy, which tells you what are the different components of an object and subcomponents of them and so on. And these 2 combine to build the canonical form of a system view. So that's what that's the way UML tries to take a look at it. This was primarily introduced by Grady Butch, one of the initial promoters of UML, and that's where I've taken this diagram from. And we have already seen that the class diagram is a problem domain model to be used in the requirements phase, as well as in the analysis phase as a structural model. It's primarily a structural diagram. And finally, in the design phase as a design model, right? So the same class
Sir, you are not audible.
Can you hear me again? I had lost connection.
Yes, sir.
Okay. I'll get back to the presentation. It's a regular problem of network anyway. So I'm back to slide 8 in this module. I hope you can see that. So class diagram also features finally in the design phase. Whereafter we engage in the high-level design to the low-level design, where implementation classes are added. And by this time, you have possibly made a choice of your implementation language. So in many cases, the class diagram starts getting converted into or translated into actually code skeletons in the target languages. Okay, so that's a basic role of the class diagram. So it's a UML structure which shows the structure of the design system at the level of classes and interfaces, right? And there are various features, constraints, and various types of relationships between the classes. You will see that quite a bit of these relationships, like generalization, you already know. There are some more that we will introduce in the course of the discussion here. So the basic features of a class, it will sound a strong similarity with C++ or Java classes. But this is the generic concept in terms of the UML, which are taken, all these points are all taken from this particular UML 2.5 diagram overview, kind of the standard document. That a class has non-static features. A non-static feature is which characterizes the individual instance of a class, and then it has static features which represent some characteristics of the class itself. So non-static data members and static data members in C++ is what you see. Then it has structural features, is a type feature of a class that specifies the structure of the instance of the class. So this is the total layout of the data members in the class. And finally, you have behavioral features or methods that what specifies the services that will be offered by every instance of that class. So this is what you already know. This is just the terms being introduced here. Now we start introducing the notation. A class is shown in UML diagram within a rectangular, solid rectangular box, outline rectangle, and the first letter of the class name will be capitalized, and the class name will be presented in the boldface, right? So by this, you know that student is a class. Now here we have not given any details, so this is equivalent to a forward declaration in C++, you can say. But by this, in the UML diagram, you will know that this is, we are talking about a class. You can have abstract classes which cannot be instantiated, as you know, where you can say the abstract keyword is written within curly braces. So these are kind of modifiers which you can apply in different diagrams. So here we write teacher abstract, which means that teacher is a abstract class where details are not shown. You may also note that there is an alternate notation for abstract classes where you may not write this abstract within curly braces, but you can write the class name in italics. Bold, first letter capitalized, and italics means a class which is an abstract class. Right? And there are optional compartments separated by horizontal lines which will have the attributes and the method in the order. We will slowly see those. So first, the attributes or the property. So the specification of an attribute or a property in C++ Java terminology data member is the visibility definer, visibility qualifier, then the name of the property, followed by colon, then the type of this property. So this is a type definition. Then you have an optional, within the square bracket, it means optional, multiplicity as to whether it will be only one, or there'll be many of them, and so on. You may have optionally a default value to initialize, and then you can have certain property strings for these attributes. So let us look at an example, the example below. So first, for the visibility of the properties, they are denoted by plus if it is a public access, hash if it is a protected access, and minus if it is a private access, right? So you don't write these words, you just write these. A property name will be underlined if the property is static. So if you underline a property name, then it will be a static property. It will be a static attribute. A property may be qualified by these keywords. That is, it could be read-only, it could be static, it could be ordered, it could be unique, or it could be optional. If it is optional, it will indicate that it allows for a null value there. You may not have that property at a particular instance. It could have multiplicity, which bounds the constraint of size of the collection of property values. So you can say that by multiplicity, you actually kind of bring in the notion of arrays of a certain property, arrays of values in a certain property. By default, the maximum bound is 1, but it could be anything else. The default value option is an expression for the default value or the value of the property. Some properties are derived. They are not specified by instantiation, but they are derived. And such properties are shown by a forward slash. That can be computed, but does not actually exist in the system. So while you model, you in C++ or Java, you may want to have that either as a computation as a method, or you may have that as an optional property. But in UML, what it means that this is not a value which is given, but it is computed from others. So here you see an example below. The student class you can get from the name. Actually, this name student should be centered. This is not the right way. It should be centered. So I'll correct that. Then you have all of these properties which are shown to be public. So they can be accessed directly by anyone. You have a name which is of type string, date of birth which is of type date, assuming that these are types which are already known. Then you have a roll number which is a string, and you write the qualifier unique. So you mean to say that between any two instances, the roll number cannot be same. It has to be unique. Whereas you did not say that for date of birth or for name, because they can match. Two different students may have the same name or the same date of birth. Then you have subject, which is of type subject, which may be another class. And you put a multiplicity there. So you said 1 ... star, which means that it could be one, at least one subject, or it could be 2 or 3 or any number of them. Right? And finally, you have age, where you say that plus / age is integer, which means that age is not a property that you will put, but it can be computed. So obviously, it will change depending on the date on which this computation is done. And that's the reason it is a derived property. And it can be computed from the date of birth, right? So this is how you model the student in the property part of the class diagram. Moving on, you have operations or methods. Again, you have visibility, the name of the operation, the name of the parameter and type. You could have more than one parameter also. You have colon, return type. Here you can see that the notation wise, the type always comes after the name. Like in C++ or Java, the type comes first and the name comes later on. This is kind of the Pascal style. So you have the return type, and finally the property string. Visibility is same, plus, hash, and minus. Operation name is underlined if it is static. If it is italicized, then it means that this particular operation is abstract, which means that it is in C++ terms, it means it is a pure virtual method, right? Which is there, but will probably not have an implementation. Return type is optional. If there is no return type, nothing is returned. It's just a procedure being executed as a method. And an operation can be read-only, which means kind of const. It could be static, it could be ordered, it could be unique, abstract, sequential, guarded, concurrent. So you can see that there are properties which you do not really see in C++, and these are targeted towards programming, parallel programming or parallel execution models or thread programming, you can say. So you are saying if you say an operation is concurrent, that it means that it is a reentrant method, and two executions of this method can happen at the same time in concurrent manner. If it is guarded, then it means that there is a precondition on which this property will fire, or otherwise by default everything is sequential and so on. Right. So again, you write it in the same way after the class name, which should have been centered. You have the attribute or the property set, the attributes, and then you have the operations or methods after this horizontal separator. You have record attendance, which is taken to be protected, so it can be derived later on. We'll see how it is done. Returns a bool. You can get certificate, which gives you a certificate with the multiplicity star. So you can get 1, 0 or more certificates, but the certificates have to be unique. They cannot be same between two instances, and they'll feature in an ordered manner. You can change the subject, which is a private method given a subject, which the parameter is being shown here, given a parameter type, parameter s of type subject, and returns a bool type. You can have calculate age, which gives you an integer, which will actually give you this age property. Then you can have other kinds of like book music class slots, which gives you bool, true or false, depending on whether it is succeeded. And you say it is concurrent, which means that multiple requests for music classes could execute on this property at the same time. Right. So this is kind of the, there are more details, but this is roughly what you use 80% of the time, and would help your understanding in understanding a class diagram. So we have seen the live management system. So if we look into that, then we can say that these are some of the classes, that class diagrams that we can have. We have an employee, which is abstract, which has a name, employee ID, gender, which is male or female, on duty, which is Boolean, so it's true on duty, false not on duty, salary, which is double, date of joining, reports to, which is the name of the employee this employee is reporting to. And you have different methods of recording attendance, request leave, cancel leave, avail leave, export leave, and so on. Similarly, there's another class diagram for leave, which is also abstract. You have the start date, end date, the status, whether it is a new leave or it is an approved one. Then you have a derived property is valid. So you do not know when you are entering the leave or instantiating a leave as to whether it will be valid or not. So it is derived through some computation, which is given here as a method is valid, which will compute this Boolean. So this is a derived property. You have a type of leave, you have approved condition, employee ID, and then you have different methods to operate on this leave. So this is the kind of abstract classes for an LMS system. There would be many, but I'm just showing you the initial ones so that you can get. So here, let me show you. I hope you can see this well. A class diagram for a library domain model. Think about a library, right? We all know what a library is. So you have a book as a class. You can see that it is written as in italics, which mean that this is an abstract class. which has different properties like ISBN number, name of the book, subject, overview, publisher, publication date, language. Other than publication date, rest of it are strings and so on. And then you have as entity a book item, which is a concrete class, which has which is a, I mean, this notation, you know, is a specialization of book. So it's a particular, you know, instance of a book which has a barcode, a tag, the ISBN subject, and all of that. And there are a number of derived properties like loan period, due date, overdue. So what you are creating here is not only the details of the book, which will come from the abstract class, but you are taking only those like ISBN and subject, which you need from the book, abstract book. ISBN and subject is not. These are obtained from the abstract base class. Whereas rest of the properties, so you can see a small hat in front, which tells that you are using the property of the base class, whereas the rest of the properties are defined for this item, which is primarily talking about your you know, some of the details, more details, and also the fact that the book will need to get borrowed, right? On the other side, here you have an author, which has a name, a biography, and a birth date. I mean, you're just keeping it simple. You have an account, which is kind of the account of a person. Who is you can say is a library account of your person. So you have a library card, so that's an account. So you have the number, the history, when it was opened, the state of the account, and so on. And then you have the library, which is the name of the library where it occurs, the Central Library of IIT Kharagpur. Address is IIT Kharagpur Academic Campus, and so on. Then you have patron, who are actually the different account holders with their addresses. You have the librarian, which who is kind of manages the library. You have a catalog of books and so on. And you have two interfaces here, which is search and manage. Right? These are the two interfaces primarily you need to know. In addition, in the corner, you can see a number of diagrams are shown here, which are kind of, you know, specialized class diagram, I can say, that which say that these are the data types I'm using. So there would be possibly a separate class diagram where this data type will be detailed. So kind of, this is kind of a forward and extern declaration. You can say it's a data type. You can say Guillemette is always kind of saying in UML as to what it is. So it's a UML specifier. So it's a data type address. So whenever I use address, for example, here in patron or in library or in librarian, then I know that it is of this data type address. Then I have a data type which is full name. So it will be, you know, detailed somewhere else. And then we have a set of classes which are enumeration type. So it's a language, and language can take these values. You know, so we have had several discussions of classes or categories having a fixed set of possible values, like gender, having male or female, like having booking class, having AC3 tier, AC2 tier, first class, and so on. So that's the kind of enumeration. So here you say that when I talk about account state here in the account, I'm talking about this enumeration. So I am actually meaning that the state could be any one of these three: active, frozen, or closed. Or when I'm talking about format in a book item, I'm talking about these. Right. So these are simple ways to show enumeration, or you can actually within curly braces list them at the place of the type also, like you did for the gender. If I go back to slide 14, you can see we have, so this is also, I mean, I could have said enumerated gender, and then I could have shown that male and female are the two possible values that this can have, right? So these are the kind of the classes, and there are a lot of links that you can see, the relationships, associations which are involved herein. So let's go forward, and I'm showing the same diagram, and I've always given the URL reference. So whatever I'm saying here, you will find them stated in more in details in that URL also, in case if you need to refer to that. So this is an annotated annotation on the class diagram for understanding. And if I just go back one step again, one slide again to slide 15, you can see that these data types and enumerations are well understood. So we have removed that. The diagram removes that in the annotation. It has only the rest of the diagram. So it is showing you that this is an enumeration data type as a sample. These are showing these are the attributes. So this is an abstract class, as I said. This says this is a stereotype class, that is a typical class that you will get. This is a generalization. These are the attributes, as you know. Okay, and then you have a lot of other things. For example, you have something which is shown by a link like this, where on one end you have a solid filled diamond. This marks a composition. A composition stands for has a. So you read library has a catalog. So if you conceptualize library, then one component inside the library is its catalog. So if you walk into our central library and pass the front hall, and in front of that huge mural by Professor Barin Rai, you see a lot of drawers which give you the catalog in subject, author, accession number kind of, DDC number kind of ways. So that's a catalog. So a library has a catalog. Right. And then we have something which is kind of shown here with a diamond which is not filled. Diamond which is not filled, it's called has relation. So what is the difference between has a and has? We say has a is composition. So car has a wheel. It's a part of it. But car has a owner. Now, both you would think is, I mean, in English, you say it equivalently. You say car has a wheel, car has a owner. But in conceptual terms, a wheel is a constituent part of the car. You cannot think about a car, take a car away without its wheel. But a owner is a mere aggregation. It is a linked information telling you who owns that car, right? Similarly, a library has its users. Library has its catalog. Catalog is an integral part of the library. It's a component of the library. Whereas the user is not an integral part of the library. User has her own entity, is a separate entity altogether, but has an association with the library being a user. So that's called an aggregation. We will come across more terms in this also, like composition often is called strong aggregation, and whatever we are calling aggregation is often called weak aggregation. Composition is has a relationship, aggregation is has relationship. I remember while I was working on clarifications on assignment 3, some of you, I'm forgetting the name, I'm sorry, asked that in a booking, should the passenger be a component? I mean, booking has a passenger. It is in English, it is true, but it is not a part of relationship. Passenger is not a component of the booking, but passenger is related to by the reservation to the booking. So booking has passenger, but booking has a date. That is a component of the booking. So that's the kind of notional difference that you get here. Okay, having said that, then there are simple associations that you associate a catalog with a book item and so record. So there's a simple association. There is associations in this way, relationships in this way, where between two classes we say that who, like, what is the relation between author and book? The author, again, the book does not have the author. It's not a has a relationship. It is not also has relationship in that way, right? Because it's stronger than that. So we say it is a wrote relationship. The author wrote the book, and this arrow, this black arrow, has a direction of reading, because you are connecting it by a line. So you read it in the direction of the arrow. So you say author wrote the book, account borrowed the book item, account reserved the book item, and so on. And when you have such a relationship, then on two sides you show the multiplicity of entities, right? So you say that one dot dot star, one dot dot star, which means that one author here may have written multiple books, which is true. I know Donald Knuth has written so many books. Also, you say that book has one dot dot author, which means a book may be written by one author. At least one author has to be there, but it could be more. A book can be written by multiple authors, right? So you say that that book on C compiler on C language is written by Kernighan and Ritchie. So the book C language has two authors, Kernighan and Ritchie, whereas a book C++ language has only one author, Strauss-Stroop. But Strauss-Stroop has multiple books. So that's the notion of multiplicity in a relationship. I'll talk about this more formally, but just taking it together, I'm trying to give you the whole feel of the class and diagrams and associations so that you can create your own. So here you are saying that account, and if you do not specify a multiplicity, then it means one. So it says one account borrowed 0 to 12, which tells you that what is the maximum number of book items you can borrow at a time. So you may not have borrowed anything. You can borrow one book, two book, but you cannot borrow more than 12 books at the same time. So this says that the relationship, that is all specified. So you can see that these all had been written in the specification document with a lot of sentences and possible ambiguities, and they are being extracted and put in a very compact diagrammatic pictorial form without any confusion that can happen. Similarly, account reserved 0 to 3. So it may not have reserved any book. It may have reserved 1, 2, or maximum up to 3 books. So here you can see the association of records, catalog records book items. So there is only one catalog. So all book items of the library will go to one catalog only. You can understand that catalog will eventually turn out to be a singleton, like the library itself. But on this side, on the book item side, it is star. So the catalog will have any number of books. And at the extreme, it may not have any books at all. So similarly, in terms of composition, you see that the library has a catalog, no number given, so it has only one catalog. So which tells that the catalog is a singleton, right? That is the way to write and read this diagram. Whereas if I look into this aggregation from library to book item, I see there is a star, so a library can have multiple book items, which is obviously true. In this association, in this aggregation, library is one, and you have star on the account. So a library can have multiple accounts, but every account belongs to the same library. or has the library that has this account is only one. So library turns out to be a singleton as well, right? So, but there's nothing as such written in terms of here. Then there's a librarian, and then you have some more, kind of use information. For example, you say that account use the account state because you are using it here. So that makes it clear as to what is the enumeration type that you need for defining this account class type. You can say that the patron use, so you can see these are information which are actually coming from your use case diagram and kind of getting embedded in a very crisp manner in your class diagram. So patron use search, librarian use search, but librarian also manage search, also manage the catalog, but certainly patron does not manage it. So the use relation is not here. So use case wise, search use case will have two actors, patron and librarian, whereas manage use case will have only one actor, which is a librarian. And then you said these are interfaces, which means that they just have the the method, the behavior that you need, but no implementation. So you have these kind of specialization, which is a dotted hashed line you can see with kind of generalization notation of a non-filled triangle at the end. This is called interface realization. So these interfaces are implemented by catalog. So if you have been more accustomed to Java programming, you will see this really map to the interfaces and implements kind of mechanism that Java has, right? So this is to give you an overall feel of a relatively blown up library domain model. And naturally, the expectation would be that in assignment 4, you will be able to do such a diagram for your booking assignment. Okay, so let me. I'm sorry. Before I get into the next associations and all, let me stop for a while. I'll now. I've talked about almost everything. But I will detail them formally now. But before that, let me ask if you have any question. No questions? Yeah, you are all smart.
Are weak aggregations like bound to be nullable? Like, you're referring to weak aggregation means it is not a. It is in English we would say has a, but it is not essential or it's not a part of the thing.
It's not. It's not a component of that. It's not a constituent of that. But it is related to that. Actually, what you mean is related to that. So car has an owner. Owner is not inside the car, but wheel is a part of the car. You cannot. You take out the wheel, then the car is not complete. Right. So that's
our weak like things that are described as weak aggregations by default nullable.
It could be nullable. I mean, not by default nullable. You can define whether it is nullable. Okay. Right. You could say that okay, there is a relationship and it has to be there. Right.
But it's still weak.
It's still weak. For example, the owner of the car. Once you can say that you have a car which is abstract and you have specialized that as a registered car, right? A car which has been registered, right? The moment you have a registered car, the owner still is has relationship, but it is not nullable. You cannot have a registration without a owner, right? You can have a resale, you can do first value everything, but it will always have to have a owner. Are you getting that?
Yes, sir.
So but if you think about car, then at the level of car, it may be nullable because the car has been manufactured. It has come to the showroom. It does not have a owner. Okay.
Yes, sir.
Right. So these are the fine nuances that you can play around with. I mean that's a big fun of this.
So there is flexibility.
There is flexibility. I mean, all kinds of flexibility are there in UML to be able to capture the notions that you typically write in a specification document in terms of very concrete notation. So when I write in that notation, then there is no two ways of interpreting it. Right. So what does string 0 to 1 mean? The string 0 to 1 means that it can be it is a 2-length string of ID. Right. Let me go back and continue on this. So I'm back to module 27. These are the things that we are going to discuss more specifically. So kind of quick recap. These are the things we have done differently in discussing C++. Here in module 14 also. So just showing what is the notion of relationship. So what we are trying to do is we are trying to talk about varied kinds of relationships that you can have among classes, right? So there is association, weak aggregation, strong aggregation, generalization, constraints, and all of that. So if you look at the relationships, then we have seen Daisy is a kind of flower, which is called a sharing connection. Daisy is a flower. Rose is a flower, right? This is a sharing connection, right? The properties are shared. Red roses and yellow roses are both kinds of roses. So red rose is a rose, yellow rose is a rose. You'll say this is a semantic connection. You know, this is not kind of having the same properties, but semantically they are related. A petal has flower has a petal is a semantic connection. Whereas you can have behavioral connection or called the symbiotic connections. Like ladybugs eat certain pets such as aphids, I do not know what they are, which may be infesting certain kind of flowers, right? So there is a relationship which is a kind of a symbiotic relationship, semantic dependency. For example, one extreme example, from Butch, roses and candle, are they related? In several contexts they are not, but in the context of say decorating dinner table, or in the context of birthdays, in the context of Valentine days, we can say that they are related because they semantically take part in a common activity, right? So these are different kinds of relationships that can actually happen. So every time a relationship happens between two classes, you just draw a line connecting them. It's most general, most semantically weak dependencies, and everything is bidirectional. But then you refine to specific relationships. Two are the most important. One is is-a, which you already know, and the other is has-a, which also you know, right? And some relationship may just remain to be a link with more properties written onto that. So a particular type of association is could be of varied kinds. So this is a kind of a meta model which say that I have association, and then I have binary association, which is written as it's an association between two classes. Association is general. It could be, you could have an association to itself. It could be reflexive. So it's a line connecting with a label is what defines a logical such connection. Or I can have a n-ary association. We'll see examples where you just use a diamond having linked lines to n number of classes, of course, more than 2. Then binary association will be of two kinds, primarily aggregation, as we talked about, has, and composition, that is has-a. So these are the typical kinds of associations that we'll have. So let's see. So here is an example of association, which I just talked about earlier, that you have a class professor, a class book. They are related. There's a relationship. So you draw a line, and then you qualify this. You have the two association ends. You have navigability, that is from which direction to which direction, and you have arity. So you say 1 dot dot star, 0 dot dot star. I mean, just see the subtle difference between what we saw in the library domain model and what we see here. In the library domain model, we did author one dot dot star, and text and book we did one dot dot star. Because if someone is an author, he or she must have authored a book. But that is not true for a professor. There may be a professor who has not authored any book at all. So that is why you you put a value 0 here. You start from 0 because author may not have wrote a book. Whereas for a book, you need at least one author. So it starts from 1. And then at the end, you could optionally, of course, most of these are optional. You could put the common name of this for this relationship, for this association, that, well, a professor wrote a book, which means an author actually wrote a textbook, is what you are meaning. And this is the name of the relation and the direction. So association, so this is what you write here is kind of what you say is a role of the object in that particular relation. Professor is a generic entity. I mean, I'm a professor, but I have multiple roles. I may be an author, I may be an instructor, I may be an administrator, I may be an editor, and so on. So there could be multiple relationships between the professor class and several different other classes. And in a particular relationship, I might want to refer to a particular role that this entities from this class is playing. So professor plays an author role in this relationship. In another, she could play an editor's role or an instructor's role. So if I have a professor and subject and the relationship is teaches, then I'll say that professor in place of author, we will write teacher or instructor, something like that. Right? So that's the kind of semantics we put here. The association end could be owned either by end class or by association itself. So what it means, let me go back. So these are the two ends of the association. So here, these are owned by the end classes. Like professor owns this end of the association, one dot dot star author, or book owns this part. Or I can say that the association itself could own the ends. So association builds is owned by the query. I mean, it's owned by classifier, and association query builder is owned by the association build itself. Right. So that's a kind of thing. Navigability is a direction, as you have seen, and navigability can be specialized in multiple ways. You may not show any direction for the navigability, right? So it's unspecified navigability. Right. You could say that it A4 to B4, or say, let's go in this order. So A2 to B2, where A2 has unspecified navigability, while B2 is navigable from A2. So you can relate from A2 to B2. What you can do on A2 is not. No. You can cross it out to say that A3 is not navigable from B3, but B3 has an unspecified navigability. You might navigate there, you may not. Here you have A4 is not navigable from B4, but B4 is navigable from A4. You can have bidirectional navigability. You can have no navigability at all. So you could decide and express that whether your relationship could navigate from one class to the other. Now, naturally, what is the most important in association is the binary association. So it is rendered by connecting two classifiers by a solid connecting line. So this basically means that job and ER classes are associated. It just says that much. Then you can have something like a relationship like this, where you say the car was designed in the year. This is the reading order, right? Or you can have a NRE association which relates more than two classes. So it's a car, year, and then you have design bureau. I mean, who did the design? Several cars that we see as being marketed by Maruti are designed by Suzuki. So design bureau could be Suzuki, and design relationship itself, the association itself, could have multiple properties to relate these three together. You all haven't done databases yet, right? You are in second year, yes, okay. So when you go to do databases, you will see, all of these being used heavily. So actually, this will help you there as well. UML is a language which is often, at least many parts of UML, particularly this use class diagram kind of things are often used in database design as well. So here we have another example of a healthcare organization. So I will leave it for you to study more. If you have difficulties, you can always go there. So I have a patient as a class which has a imaging service request. It may have 0 or more, which has a requested procedure as a part of the imaging service, which a procedure has a scheduled procedure step, which is a part of the requested procedure. Scheduled procedure step has protocol code. If you are not familiar with medical procedures, you'll find this chain little difficult to understand, but more or less you will get an idea. Whereas a patient has a service episode, and that service episode is not a part of the patient information. It's actually a related concept. The facilities and so on, you can take your time, try to understand this, and you'll get more insight into the class diagrams here. These are associations in the LMS. Employee is an abstract class. Executive is a generalization, binary relation, binary relation, binary relation. And then you have, these are leave approval links on the left. So you have not shown the direction, you've kept it unspecified navigability, which is not good. I could have specified that, but that's just the first level abstract view. And then you have a collection of employees here. So it is a weak aggregation of the employees, any number of them. And then you have request leave, which has one on the side, star on the other. So many executives could request leave, could report to one lead. Similarly for the manager and so on. Right? So you can see it in here. So this is what specifically brings us to what we have been discussing. Is you can again go back to module 14 and you can read more about these concepts. So one is a whole or part relationship. As I said, that flower has a petal and library has user. So one is physical containment and another is a conceptual containment. Car has a owner is a conceptual containment. Car has a will is a physical containment. So that's a composition of strong aggregation. This is weak aggregation, or often called just aggregation. Right? So this is how you write the weak aggregation. You have already seen this. Triangle has weak aggregation with line segments. There are a whole lot of line segments. Any three of them behaving as sides could form a triangle. Right? So yes, in that sense, you can define it in a different notion also. You can just say that I just have three segments and that is the triangle, so it's contained. But then it does not get related to the whole class of segments which may have thousands of segments. So here we are depicting that if we have a whole lot of line segments, then three of them could be weakly aggregated to form a triangle. So it is a weak aggregation component. We can further say that these have to be unique, that you do not allow degenerate triangle. So the segments will have to be unique. Whereas you can have a strong aggregation. I say I have a folder, and I put files inside that. So this is a parent folder where I put in file, and all files that I put in go into one folder. So multiple files can go into one folder, and therefore it becomes a physical containment. A folder is a physical containment of files. Whether you take a physical folder or you take a Windows folder, this is a, but when you create a shortcut, it becomes a weak aggregation because you are just referring to it. It's not a physical containment, right? But any files, other folders, being a part of the folder is a strong aggregation. Right? Back to the library domain model, this annotation. So here you have seen the composition aggregation we have explained already. So that's, I think we'll stop here. I'll continue again tomorrow. Before that, let me see if there are further questions. Let me try to clarify. Yes. Do you have questions up to what we have discussed, the first two modules of class diagrams in UML? There's a question by Ayan Singh. What are you saying? Let me go back. Ayan, why do you think that there's a typo? There's a mistake? Patron is a user and patron has account. On, are you there? On? So this is a has relationship. This is an aggregation. I mean, we haven't written one here. We could have written that to mean that account has a single patron, unless you have, unless you allow account by joint holders, which in library typically you don't do. If you have a bank account kind of system, then you will model it here by allowing for joint accounts which are held by multiple customers. But otherwise, patron has account, so it's but patron has a name, so it becomes a component here. But we didn't show it separately because it's of a base data type, and we show it as a property of patron itself. Right. So you can see that has has a mixed has a mixed connotation. I mean, we have used has a to just show the data members, but has a could be even beyond the data members. You will possibly then finally in the language you will possibly have a kind of a data member in library showing catalog, or you will have some weak relationship to finally model it in your language. But conceptually you have to look at whether it's a physical containment or it's a conceptual containment. Or possibly is not being able to connect. It's already time, so thank you all very much. See you tomorrow in the morning at 8, and we will continue on this discussion and then go over to the sequence diagram discussions. Thank you very much. Have a nice day.